These are the two conversions that I am currently making for these little cars. On the left is a 5-speed manual transmission conversion, and on the right is an automatic transmission conversion. They both use the same intake manifold, the same carburetor, same adapter plate, same throttle cable bracket. But there are some nuanced differences between a manual transmission and an automatic transmission installation. Five-speed manual transmission conversions are very simple. You only have one connection that you really need to worry about, and that is the throttle cable. You run the throttle cable through this plastic throttle ball end, put a cable stop on it, and you're ready to put the carburetor into service. Automatic transmission conversions are a little more complicated. There's a couple of things that need to be set up before the carburetor is put into service. First is the cable that controls the governor inside the transmission that determines the shift points. This is your throttle cable. You run the cable through here and put a cable stop on it, just like a 5-speed conversion. But there's a second cable that goes in here that goes to your transmission. And as this cable moves towards the firewall, this cable gets pulled towards the rear of the car, and it pulls on the governor inside the transmission, and that will control how many RPMs your engine will be spinning before the transmission shifts gears. The second thing that you have to set up is the full throttle kick-down microswitch. This is what tells the transmission to shift into the next lower gear when you press the accelerator pedal all the way to the floor. For example, if you're passing somebody on the highway. Now this is a K-jet microswitch. What you do is you just unbolt it from your K-jet installation and transfer it to your carb installation. And this is what that bracket looks like behind the microswitch, and it has two slots that allow you to adjust the microswitch fore and aft, so that way when you open the throttle plates all the way, it triggers the microswitch. The last thing to show you is this kicker solenoid. You can wire this solenoid into the pink wire that engages the AC compressor clutch, and then whenever the compressor is engaged, the solenoid will kick out and press on the throttle linkage, and that allows you to bump up the idle speed when both the compressor is engaged and you have the load of the torque converter. And you use this adjusting screw here to move the solenoid fore and aft to control how much it presses against the throttle linkage. These are the barbs that connect your vacuum lines. This is 5/16. This is PCV. It goes from the oil filler cap through the PCV valve and then into the PCV passages that are cast into the carb base. this is 3/8, which is HVAC brake booster. This goes to the T that is against the firewall and then splits the vacuum line between the HVAC ductwork and the vacuum canister on the brake booster. And then the 5-speed has a plug where the automatic conversion has a 3/16 barb. This goes to the modulator valve that is in the front of the automatic transmission. And then they both have ported vacuum that goes directly to vacuum advance on the distributor. So those are your vacuum line attachment points, and I'll show you when we install this manifold. I'm going to start the conversion in the front of the car and work my way towards the rear. So this is what goes into the fuel tank. You start with a baffle. This baffle is made out of 304 stainless steel. And you see it's got a series of little holes drilled around the base. That will allow fuel into the baffle even if the level of fuel in your tank drops below the lip on the edge of the baffle. But because the holes are small, the fuel won't escape, and it'll keep your pickup submerged in fuel as you go around corners and go up hills and things like that. And then this is the pickup that just sits in the baffle like that. And what looks like a fuel filter down at the base of the baffle is actually a 300 micron pickup screen. And what that does is it filters out the big pieces of trash that tend to accumulate in fuel tanks. You can see I got bits of trash in my baffle. And by the way, that is a tuna fish baffle. The infamous tuna fish baffle that dates all the way back to 2004. So the tuna fish baffles are eminently suitable, but I've started using 304 stainless baffles since. And there's the pickup installed in the tank. Now we need to run a piece of hose from here to the old K-Jet return line. We're going to repurpose the old K-Jet return line as a front to rear fuel line. So we need to run a piece of hose from here to here. And there's our hose connecting the pickup to the old return line. There is a T in the K-Jet return line that ordinarily goes to the backside of the accumulator. Now theoretically you could leave that hose in place, but if the accumulator ever leaks internally, if the diaphragm in the accumulator ever goes bad, you will end up sucking air rather than fuel from the tank. Now I provide a barbed plug, and I even provide a length of fresh hose that you can use to cap off that T in the return line, and then you're guaranteed never to suck air. It's a little bit easier to cap off the T in the old return line if you pull the accumulator out. And then of course once the accumulator's out, it'd be silly to put it back in. On my own car, I use the length of hose to join together the inlet and the outlet of the old outbound fuel line, just to keep trash out of them. And then that's the length of hose that I use to cap off the T in the old return line, which is now being used as a front to rear fuel line. Now it's time to install the fuel pump. This conversion is going to be using a mechanical fuel pump operated by a lobe on the end of the passenger camshaft. Now all DeLoreans have a place to mount a mechanical fuel pump. From the factory, that mounting location is covered up with a plate. We're going to remove that plate and mount the mechanical fuel pump where the plate used to be. And there's the fuel pump mounted where the cover plate used to be. Now for the purposes of this video, I'm putting my old pump, my usual pump, back on the car. The owner will of course be getting a brand new pump. And I also use studs with stainless steel nuts and washers to hold the pump to the cylinder head. I find the studs are easier to install and easier to remove if you ever need to take the pump off. Now I need to run a piece of hose from the pump to the far end of the K-Jet, the old K-Jet return line. And there's the hose connecting the far end of the K-Jet return line to the fuel pump. These are the plugs that I supply in fresh boots to plug the old fuel injector bungs. The plug is the same size as a fuel injector. Now my cylinder heads were never drilled for fuel injectors, so I can't show you these installed, but this is where they would go, and you get 6 of them to plug all the old fuel injector bungs. To seal the intake manifold to the cylinder heads, I use square profile O-rings. These have a square cross-section rather than a round cross-section. And I find that these just seal better than the round O-rings. They're basically a pre-flattened O-ring. And they of course go on each intake port. Every carb conversion gets test driven on my own car first, and after I'm finished test driving it, I just unbolt the intake manifold from the cylinder heads and leave the carburetor bolted to the intake manifold. So all the owner has to do is pick them up as a unit and drop them onto the engine. The intake manifold is held on with the same 4 bolt holes that held the K-Jet manifold. Obviously you want to observe the same precautions, not to cross thread the bolts, not to over torque the bolts. the fuel filter screws into the front of the carburetor. This is a standard Ford fuel filter installation. The threads are tapered. They're self-sealing. Do not over tighten the fuel filter into the carburetor, or you'll end up damaging the seal where the two halves of the fuel filter are crimped together. It needs to be tight enough that it doesn't leak, but not so tight that you damage the crimped seal. A metal fuel line connects the carburetor to the fuel pump. This is a compression fitting, so you use a 9/16 wrench to turn the compression nut. And then this is a flare fitting. So you put a 1/2-inch flare wrench on the flare nut, and when it's ready to be tightened to the fuel filter, you put an 11/16 wrench on the fuel filter and squeeze them together. Because the carburetor's throttle attachment point is way back here, whereas the old K-Jet throttle spool was way out here, the throttle cable outer sheath needs to be cut shorter. Only the outer sheath gets cut shorter. The cable itself inside the sheath stays longer. Pull the cable back at the accelerator pedal so you don't accidentally cut it at the same time you're cutting the outer sheath. If you accidentally cut the inner cable too short, I send 2 cable stops with each conversion, so you can use the second cable stop at the accelerator pedal and run a new interior cable using 1/16 wire rope. And I have a video on YouTube showing you how to do that. When you're putting the end on the throttle cable and tightening the cable stop, make sure you do not position it back too far and prevent the throttle plates from closing all the way. Right now, this carburetor is in its choke settings. You can tell that because not only is the choke plate fully closed, but the rod that connects the choke mechanism to the fast idle cam is all the way up. That means that the throttle plates right now are cracked open slightly. If I was to position the throttle cable end and tighten the cable stop with the carburetor in its cold choke settings, it would be positioned back too far. So what I need to do is to put the carburetor in its warm choke settings manually, which will then close the throttle plates completely. Then I can position the cable end and tighten the cable stop. To do that, I'm going to take tension off of the fast idle cam by cracking open the throttle plates. While holding them open, I will push down on the choke connecting rod. That'll move the fast idle cam out of the way. Then I can let the throttle plates close again, and the choke will be in its warm choke settings. The fast idle cam will be rotated manually all the way around, and the throttle plates will be closed completely. And you'll be able to tell because not only will the choke plate be cracked open, but the choke mechanism connecting rod will be in its down position. rather than in its up position. With one hand, I take the tension off the fast idle cam, then I push down on the choke connecting rod. I let the throttle plates reclose. Now the carburetor is in its warm choke setting. The throttle plate is cracked open and the choke connecting rod is down rather than up. Now I can position the throttle cable end and tighten the cable stop in such a way that it will not be preventing the throttle plates from closing all the way. This carburetor uses electrical resistance to heat up the spring inside the choke cap that operates the choke mechanism. So this choke cap needs to be connected to a 12-volt wire that is keyed to ignition. Now, I do not recommend repurposing one of the old K-Jet power leads because those all pass through the bulkhead connectors. And if you ever decide to remove your disused bulkhead lines, as I have done, you could inadvertently remove the line that is powering your choke cap. What I've done on my own car is I've run this wire through the same grommet as the distributor pickup wires, and I've attached it to the power lead that used to power my old idle speed ECU in the ECU compartment. So even though I have removed my disused K-Jet wiring from the bulkhead connectors, I have not accidentally severed the power lead that is warming up my choke heater. As mentioned, there are 3 vacuum lines. This is the 5/16 PCV line from the oil filler cap. That is the 3/8 HVAC brake booster line. And then this is the 3/16 Spark Advance ported vacuum line. Unlike a DeLorean, there's no cutoff solenoid. The Spark Advance line goes directly to the Spark Advance diaphragm, just like a Volvo. Right now, the bowl for the carburetor is totally empty. There's not a drop of fuel in it. And the carburetor cannot work like that. The carburetor needs fuel in the bowl to operate. Now, to move fuel from the front of the car all the way to the rear of the car and fill the bowl high enough to start drafting fuel will require an extended period of cranking. We'll have to crank and crank and crank and crank and crank the engine to operate the mechanical fuel pump to move all that fuel. So what I like to do is to manually fill the carburetor so I don't have to crank the engine so much to fill the bowl. And I have found that a rattle can cap is a good size for fuel to fill the carburetor. And I use a little funnel to get the fuel into the carburetor. And then I fill it up. I made a little bit of a mess while filling the carburetor, so I think I'm going to wait for just a minute for all that fuel to evaporate from the outside of the carburetor before I start the engine. All of the fuel that I dribbled has evaporated, so now I'm going to start the engine. Fire extinguisher just in case. I've put the carburetor in its warm choke settings to show you what it would look like first thing in the morning, and then all you have to do is just move the throttle linkage just a little bit. Just press on the accelerator pedal just a little bit and it will reset the choke and put it back into its cold choke settings. And this is what they call fast idle. The fast idle cam is on its highest setting, which is pressing just a little bit on the throttle plate. And if you bump the throttle linkage, as the choke warms up, it'll put it in the normal idle. Although I think this is the intermediate setting here. There's no fuel leaking. Turn that idle speed down just a hair. But that is how you install a manual 5-speed carb conversion. This is what it looks like with the air filter in place. This is my air filter. I'm not going to get Chris's all dirty. But this is the barb that the fresh air hose for PCV attaches to. And so that is what a complete carb conversion looks like. This is now ready to be test driven.